So today I want to talk about circles. And when we're measuring a circle, the easiest thing to do from an engineering point of view, if we have a piece of rope, for example, and we want to measure its size, easiest way to measure it is with a caliper instrument like this. So if I want to measure this rope, I'm going to measure its diameter because that's what I can measure. And that diameter is about 5 millimeters. So this rope has a diameter of about 5 millimeters. So the circumference around this is 5 millimeters, going around the outside of the rope, the circumference is around pi times 5 millimeters. And this constant pi, been around for a long time, but Leonhard Euler in 1748 used the Greek letter pi. Originally, the Greek letter pi meant, of course, perimetros, which is Greek for perimeter, and that's the perimeter around the rope. They often used pi over delta for diameter, or pi over rho for radius. But the letter pi by itself as a constant came into popularity with Leonhard Euler in 1748, and Euler used pi actually for the ratio of the radius to the circumference originally, which is about 6.28. He interchangeably went back and forth. He used the letter pi to represent a quarter of a turn. Sometimes he used the letter pi to represent half a turn, and sometimes he used the letter pi to represent a full turn depending on the context, much like we might use theta as an arbitrary angle. And in 1958, Albert Eagle suggested the use of the Greek letter tau to represent a quarter of a turn. So pi plus pi is the full circle. These are the two half circles. Or if I make this, there's tau plus another tau plus pi is equal to 2/4 plus the half, or you can say tau plus tau plus tau plus tau equals circle. And there's our new symbol. In 2001, Bob Pele proposed this symbol for 2 pi. Then, in 2010, there was the Tau Manifesto. In the Tau Manifesto, the idea is tau was equal to 4 times what it used to be, 4 times the Albert Eagle tau, and this is tau. Tau sub mh is equal to 4 times tau sub ae. If we have 2 different versions of tau now, that's a new version of tau that emerged in 2010. So that is equal to 2 pi, by the way, which is the full circle. This was self-published, I guess, on the web, but I was looking around to try to find scientific literature that, instead of Manifesto, of people actually using it. I was able to come across a PhD thesis that actually uses that version of tau, but that thesis, tau occurs twice in the definition, and then it's used 8 times. And of those 8 times, it's only used 2 times as a constant, as the circle constant, and it's used 6 other times as just a variable. In other words, if we have something like S and T, we'll use something like sigma and tau and other variables. Like S is often used in conjunction with sigma, and T is often used in conjunction with tau as variables. So tau is used quite often as a variable, even in a paper that fully embraces and references and cites this Tau Manifesto. So this is the same problem that I'm coming across, is that we use tau as a time constant, we use tau as an time variable integration. Now, in electrical engineering, we often use tau to represent time constants or integration variables, such as, the integral of some function of t minus tau times something, whatever, d tau. And so in electrical engineering, it's very hard to dissociate the letter tau with time. It's a time variable, almost always. Time constants of systems and so forth. So therefore, we often look for another letter. And so what other letter would be appropriate? Well, one letter that would be very appropriate is the ancient Hebrew letter teth, the ancient Phoenician letter teth. So the ancient letter teth, this is a modern Jewish square script, but in the older fonts, the ancient letter teth was a wheel with 4 spokes, which meant spinning wheel or circle or disc. And so this is the Hebrew letter teth, which is also the indigenous medicine wheel symbol, the same shape. And it means circle or wheel. And it's almost a universal symbol. In the Phoenician font, sometimes you'll see it'll sort of look like this. And in the modern Hebrew, it'll sort of look like this. And teth, and this is kind of nice because it suggests turning. It suggests a turn. So this is 1 turn. So half a turn is, teth by 2. That's pi. Or teth is a full turn, teth by 4. Which is tau is a quarter turn, and so on. This is half turn, and so on. And so this is a very natural letter to use for representing a turn or a circle. Now, interestingly, Thomas Kuhl in 2008 suggested the use of the capital theta, the capital Greek letter theta, to represent the full circle. This is equal to 2 pi. And that also makes a lot of sense because theta derives from the Phoenician or Hebrew letter teth. And this also makes sense because then you've got little theta. Lowercase theta might go on a range from 0 to uppercase theta. Much as we might have a variable in computer science, we'll often have a variable, for n equals 1 to big N to maximum N, or for n equals 0 to n minus 1, for example. So that's kind of very logical to use a capital letter for the maximum possible value of that letter. So we're also quite comfortable with using capital theta for the maximum value of the variable angle theta. And so capital theta, again, is that maximum angle of 2 pi, or teth. So in my own work in the scientific literature in 2016 and in 2019, we proposed the use of the wheel variable. So we said the invention of the wheel has been around. The wheel has been around for about 5,000 years, and there's also the wheel symbol, the hieroglyphic for the wheel, the Paleo-Hebrew ancient Phoenician symbol, the 4-spoked wheel. That symbol has existed in many, many different civilizations as a symbol for spinning wheel or wheel, and even the medicine wheel, the indigenous medicine wheel in the indigenous community, is also shaped the same. And so this symbol has been around for about 5,000 years, about as long as the wheel has been around. And this symbol is the Phoenician letter teth, which means wheel. So why not use a wheel for 2 pi, a full circle? And this was kind of the idea here. Now, let's understand circles in a fun way. Here I have some rope, and let's make some circles. And so what I'm going to do, I'm going to take this piece of rope here. I'm going to fix it somewhere. I'm in this park now, and it's really easy to fixture the rope somewhere. I can just tie it, say, to this grill here. Now I've got the rope is fixed at a certain point, and then I can measure off a certain distance from here and say, okay, how far out do I go? And this is how we might construct a circle, as we're going to measure it a certain distance out from there. So we're going to come a certain distance, a certain radius out from that central point, and then we can construct a circle. Now, If I come this way, I'm directly east. If I look in a GPS coordinate, I can take a program like GPS Logger. I'm logging my GPS points, so I should be able to see the pattern that I'm moving in. I've got GPS Logger running. It's recording 1 point every second. 38, 39, 40, 41, 42. So each second it's recording one GPS point, and then as I go around here, as I walk in a circular path, it's going to record that path as a set of GPS points. Now I'm north of center, so I'm looking to the south now. I'm north of center. Now I've gone a quarter teth, a quarter of a turn. Teth by 4, which is tau in Eagle's notation. And then if I continue, now I'm due west. I'm west of my point. I started east and I'm now west. So I'm 180 degrees from where I started, and that's pi. That angle is pi, or to use Eagle's notation, it's 2 tau, or to use Cool's notation, it is half capital theta, or what we're proposing, it's half teth. And now if we keep on going until we are south of where we started, then now we're south, so now we're 3 tau, or 1.5 pi, or 3/4 teth. And if we keep right on going, we're back to the east point again. We've made one full revolution, so we're now teth, which is 2 pi, or 4 tau. So we're now a complete full revolution. We can keep on going. We can do 2 revolutions, 3 revolutions, and if we're winding coils around a transformer or inductor, we'd call those turns. We say, that's turns ratio of a transformer is, 100 turns on the primary and 200 turns on the secondary would be a step-up transformer. And so those are called turns, and a turn is a unit of angle equal to teth. So now that's 1.5 turns, doing 1.25 turns, and now that's 2 turns, 2 full turns. And if we keep going, it'll be 3 turns and 4 turns. Now here's some different attempts at the circle. So there's 1 turn, several turns, 3 turns, 2 turns. There's a few different examples. And then this is what happens if we do the indigenous medicine wheel shape, which is the same shape as the Hebrew letter teth in the old Paleo-Hebrew font. And so this is the old wheel symbol, the old wheel hieroglyphic from many different cultures, many different societies and cultures had this symbol or letter to represent wheel.